Thanks, Emily. Hello, everyone, and happy Thursday. My name is Paul Camille. I'm a product marketing engineer for the Power Switches team here within TI. And as Emily mentioned, today I'll be going over eFuses and high-side switches for industrial. Taking a look at our agenda today, we'll first start off with a brief introduction of the Power Switches portfolio. Then we'll go into eFuses and talk about what a eFuse is, as well as some of the new devices we have coming out for eFuses. Then we'll shift gears over to high-side switches, where we'll talk about what a high-side switch is and some of the new devices we have coming out for high-side switches. And then last but not least, we'll talk about some of the additional resources that are available on ti.com for you. So to start with the power switches overview, we'll first take a look at the different product families that fall underneath power switches. For power switches, we break it up into three different categories: input power protection, power distribution, and output power protection. We'll be talking mainly about eFuses and high-side switches, but underneath the power switches umbrella, there's other devices such as IDO diodes, hot swap controllers, load switches, and power boxes, which you can find more information on ti.com about. Now to switch gears over to eFuses. Taking a look at what an eFuse is, eFuses are integrated power protection switches that provide overvoltage and overcurrent protection during fault events. eFuses are typically used at the input of a system. Some of the features and benefits of an eFuse are adjustable current limiting, adjustable slew rate control to control inrush at startup, short circuit protection, over and under voltage protection, reverse current and reverse polarity protection, status and power good signals to diagnose faults and provide interrupts to MCUs, and UL recognition. The majority of TI eFuses are recognized by UL as a solid state current limiting device. Now to touch on the different topologies of an eFuse. The basic topologies are eFuses utilize a charge pump to drive internal and MOSFETs to act as protection switches. eFuses are available in two different topologies, a single FET topology as well as back-to-back FET topologies. Taking a look at the single FET topology, this consists of a single hot swap FET to enable overvoltage protection, current limiting, and slew rate control of the output. The other topology that we have are back-to-back FETs. These devices also provide the same protection of overvoltage, current limiting, and slew rate control, but also have some additional features such as reverse current blocking and reverse polarity protection, which are made possible by the blocking FET that's internal to the device. So to take a look at the landscape of what we have to offer for eFuses and hot swaps today, here's a good snapshot of the voltage and current ranges our devices cover. Hot swap controllers can support a wide variety of voltage and currents. When you take a look at our eFuses, we have two different types of eFuses, less than 30 volt eFuses and greater than 40 volt eFuses. Today, we'll be talking about two devices from our greater than 40 volt eFuse family and one device from our less than 30 volt eFuse family. The first device we'll talk about is TPS2640. This is our first 40 volt eFuse that we've released to market. TI has a large portfolio of 60 volt eFuses, but this is our first 40 volt. The device is capable of supporting up to 2 amps and has integrated back-to-back FETs with 150 milliohm of RDS on. The device can support adjustable current limit from 0.1 amps up to 2 amps. The device is offered in both a leaded package, a 6.4 millimeter package by 5 millimeter package, and a QFN device, which is available in a 5 millimeter by 4 millimeter package. The TPS2640 has many different protection features, such as overvoltage protection, slew rate control, eye monitor to monitor how much current is flowing through the pass FET, as well as an adjustable current limit. This device is released to production and is available on TI.com. Now going over to a device, our featured device from the less than 30 volt eFuse family, TPS 25947. This device is currently available on TI.com, and we can offer prototype material, which is what we say by APL, Advanced Product Launch. This device offers a wide voltage range from 2.7 volts up to 23 volts, which can cover both 3.3 volt rails all the way up to USB Type-C voltage rails. The device has integrated back-to-back FETs with a combined RDS(on) of 27 milliamps. One of the main benefits of this device is the always-on reverse current blocking with 0 DC reverse current. The blocking FET can be modulated to ensure that 0 reverse current flows through the device during a reverse current application. This makes this device advantageous for power muxing applications. Additionally, this device also has reverse polarity protection due to some internal circuitry which helps it to protect against miswiring. The TPS 25947 also has a programmable current limit from 0.5 amps all the way up to 6 amps. The TPS 25947 is available in a very small 2mm by 2mm QFN package. To take a quick look at a PowerMux example with TPS 25947, the below block diagram shows how two devices can be hooked up to provide power muxing capabilities. The next device we'll cover from the eFuse portfolio is the TPS 2661, which is a universal 4 to 20 milliamp current loop protector. This device was designed specifically to protect analog inputs which support 4 to 20 milliamp current loops. The device can support up to 50 volts plus or minus operating range on the in pin. The current drawn from the 4 to 20 milliamp loop is less than 100 nanoamps because of the external VS supply that is used for the device. The device offers 7.5 ohm MOSFET resistance to provide a low power dissipation solution for 4 to 20 milliamp current loops. The device also offers a fixed current limit of 30 milliamps with plus or minus 15% accuracy. Additionally, the device has an enable pin, which allows it to be turned off if there's ever a fault or if the 4 to 20 milliamp current loop needs to be disabled. Another feature of the device is it has a SGood pin, which can be used to signal when there's a fault on the 4 to 20 milliamp current loop. Additionally, there's protection from input side miswiring. This device is available in a 2.9 by 1.6 millimeter SOT package. This device is also in APL state, and you can find prototype samples for the device on TI.com. This device will release at the end of first quarter, where you can get production samples or production material on TI.com. Now to switch gears over to high-side switches. We'll talk about what a high-side switch is and some of the new devices coming out of that portfolio. So high-side switches. High-side switches are integrated power switches that are used to drive off-board resistive, inductive, and capacitive loads. High-side switches are generally used at the output for driving these off-board loads. Below shows a typical block diagram of a high-side switch. High-side switches have adjustable current limits, which can be adjusted via an external resistor, as well as a current sense output, which allows the system to monitor how much current is flowing through the high-side switch. Some of the benefits of the high side switches are the adjustable current limiting, which enables application scalability and capacitive load driving. The accurate current limit can also reduce the power requirements of an external power supply, saving cost for the total system. Last but not least, the current monitoring enables load diagnostics to detect wire breaks and faults to reduce downtime. Taking a look at the high side switch portfolio today, TI offers a large amount of high side switches for 12-volt automotive batteries. TI is also investing in building out its portfolio for its industrial high side switches to support 24-volt rails. The first device we released was TPS27S100. This is a single channel high side switch that can operate up to 40 volts and has a typical RDS(on) of 80 milliohms with an adjustable current limit from 0.5 amps all the way up to 4 amps. It also offers a version with current sense as well as a version with the status output. It has two different package variants, one with a QFN package with 3.5 millimeter by 4 millimeter, as well as an HTSOP version, a leaded package with 5 millimeter by 6 millimeter dimensions. And this device is currently in production on TI.com. Now to go over to one of the latest devices we released from the high side switch, industrial high side switch portfolio, TPS274160. This device is a quad channel high side switch with 160 milliohms of RDS(on) per channel. The device can operate up to 36 volts and has an accurate adjustable current limit from 250 milliamps up to 7 amps for each channel. The device also offers two different versions. Version A, which offers individual open drain status outputs for each channel, or version B, which offers a global fault as well as a current sense analog output to monitor the current flowing through each channel. With high side switches, one of the benefits of a high side switch is it integrates a VDS clamp to help with driving inductive loads. So the integrated VDS clamp has a breakdown voltage from 50 volts all the way up to 70 volts. The TPS274160 is available in a QFN 28 millimeter, QFN package with 28 pins in a 4 millimeter by 5 millimeter dimension with 0.5 millimeter pitch. This device is fully released on TI.com. Now going over to our next device that has been released last quarter, TPS27SA08. This is a single channel 8 milliohm device with a fixed current limit. It can operate up to 36 volts and has a fixed 20 amp current limit. This device can be used for very high loads up to 10 amps, which might be prevalent in different fire alarm control panels, HVAC systems, servo drives, or factory automation applications. This device is available in an HTSOP 16-pin package, which is a 5 millimeter by 6 millimeter package. And the next device we'll talk about is TPS272C45. This is the latest release from our industrial high side switch portfolio. TPS272C45 is a dual channel 4 amp switch that can work up to 36 volts. The device has 45 milliohms of RDS(on) with a max RDS(on) of 78 milliohms per channel. The device offers a low voltage bias supply, which helps to reduce the overall power dissipation of the system. Additionally, the device has a 2-level current limit, which allows for faster charge up of capacitors at startup. The device offers adjustable current limit per channel of 500 milliamps, which can be adjusted from 500 milliamps up to 4 amps. The device is available in a 24-pin QFN package with 4mm by 5mm dimension. To go a little bit more detail into the TPS 27 2C45, we'll talk about the low voltage supply of the device. The TPS 27 2C45A variant supports a low voltage bias supply through the VS pin, which can help to reduce the power dissipation inside the device. The VS pin supports either 3.3 volts or 5 volt supplies. This can greatly reduce the power dissipation in the module for any factory automation application where power dissipation is very critical. Now going over to the inrush current limiting functionality. TPS 27 2C45 can support a current limit, or has a current limit which can be increased by 2x during startup, which helps to increase the charge rate of output capacitance as well as enable bulb driving. This can be configured through the individual ILM pins for the channels, as well as the ILM D, which sets the time duration of the 2x current limit. Below shows a diagram of how the current limiting works. The T delay sets the time duration of the 2x current limit to allow for larger inrush. This can be set via an external resistor through the ILM D pin, and the current limit can be set through the individual channels, channel 1 current limit and the channel 2 current limit. Now to go over to the TPS 27 2C45 variants. The device offers 3 different variants. TPS 27 2C45A, which offers the low voltage supply, as well as an integrated inductive clamp, as well as version B, which doesn't support a low voltage supply and has the integrated inductive clamp, as well as version C, which doesn't have a low voltage supply and does not have an inductive clamp. The removal of the clamp helps to ensure that the device can handle larger inductive loads by using external TVS to provide the protection from inductive load kickback. To sum it up, there are 4 new devices that we have out of the high side switch family: TPS 27S100, the TPS 274160, and the TPS 27SA08. And last but not least, the TPS 27 2C45, which will be released to market at the end of August. But you can find prototype samples today on TI.com. Now to discuss some of the resources available to you for power switches on TI.com. If you type in TI.com/power switches, you'll go to our portal page on TI.com where you can learn more about the different offerings of power switches, either load switches, E-fuses, and hot swap controllers, high side switches, ideal diodes, and ORing controllers, power muxes, and low side switches. On this page, we also have a power switches guided search tool, which allows you to pick the right device for your system's application. We also have an ebook, which goes in depth on each of the different protection features of a power switch and why it's important in the system. Additionally, we have a technical note, which goes over E-fuses and safety certifications and why they matter in the system. And last but not least, we also have a landing page for power switches for functional safety. This landing page talks about power switches and how they fit in functional safety. So thanks everyone for the time today. This concludes our new product update. We'll be remaining on the line for the next 10 minutes or so if there's any additional questions on high side switches or eFuses. We'll be answering everything in the chat.
Thank you, Paul, and thank you everybody for attending today. Like Paul had mentioned, please feel free to hang on for a few minutes and ask any other questions in the chat. And we hope to see you next week for our webinar focused on SAR ADCs. Thank you and have a great week.
Thank you. Bye-bye.
Thank you.